and wow, I was not expecting a full house on Sunday morning talking about metrics after like a lovely Saturday night that we had yesterday. So first of all, thank you for being here. My name is Luis, one more time. Uh, Today we're gonna talk about metrics in general, but there's a lot to be covered. Am I gonna be late? Am I gonna keep it short? We'll see. So the agenda that I talked about was I want to talk about a little bit about history, like about software development, architecture, how I see, this is my personal view, how that changed across the years. Observability, and then we're going to jump into the metrics. More specifically, I want to talk about Prometheus, alert manager, node export, and how we see metrics flowing through Grafana. The importance of alerting, not only observing, but also getting notifications. And if I have time, hopefully a demo. We will see, because I made a beginner talker mistake this morning of changing code in the last minute, and imagine what happened. It was not working, but I fixed it, and maybe going to break again in the demo. We will see. And then, of course, I'm open for any questions you guys have. Real quick again about me. I'm a computer scientist. Finished college like a couple of years ago. I'm in the road for working with Python, I would say like for 10 years-ish right now. Used to live in Ireland. I work for Italnix. I'm used to work as an individual contributor at Italnix. I'm migrating to the software engineering management position right now. I'm like a technical person, even migrated to the management area. Mostly specific, I always work with Python in my career. And this is my Twitter, where I post some ideas and collab with the Python communities in different countries. All right. As I mentioned, a little bit of history. When I started working, or when I was in college yet, actually, this is how I saw what was happening in the world. Like, we were living a financial crisis across the globe. The world was trying to recover from what happened in 2028. Spain got the World Cup in soccer. Ubuntu was released in that year. I was Ubuntu user since pretty much always. Recently migrated to Macs. Instagram was about to born. That was born in October 2010. There was no Gangnam Style though. Remember that guy? It was like a fever like everywhere. And all developers, not all, but the most common architecture at that time was like monolithic applications. Microservices already was there, start trending, but was like more common find like monolithic application, especially for small startups. Like if you're starting something small, you need something quick, you go for monolithics and refactor later, right? That's good. If you are from that time, you probably like create an application like that, Python, Django, some database, whatever database, real quick, right? You get things done. You have everything packaged together, all the modules, database connections, user integration, different business logic, all in the same place, which is great for testing, very easy. You don't like integration between modules is like easier to be tested compared to when you have like more distributed environment, right? And then the microservices come and like become like trending, and people start refactoring their services into the microservices architecture. And we had it solved a lot of the problems, especially in terms of scalability, right? How you scale a monolithic application, have to scale everything together. It's going to hurt either the database or some special module for a system. Microservices solved a lot of those problems, but also brought new problems. One day you have one application, and then it starts talking to another application, and then it starts talking to another application which is not necessarily Python written, and then we have a lot of also, I would say, sidecars or helper applications to keep your application running online, and it's very easy to lose control what's going on, especially if you have like auto-scaling set up. You don't even know how many instances of your software you have running. It's not up to you anymore as a developer. This is up to the metrics that's going to talk about. So this is I just doing this parallel between monoliths and microservices. I'm not saying this is metrics are more important now than were before. They were like equally important. What I'm just saying is I personally, as a developer, feel that's more complicated observing things right now because it's growing and it's growing very fast. All right, and how do you make sure that everything you have is working? As I mentioned, it's not even up to you sometimes anymore. One day you have one application, then you create another microservice and another, and you scale it up, and now we have one instance of your application. Another day you have like 100 then, and then you scale down, and now you have 50. Who knows what's going on there? And how do you make sure things are working? If they are working, how do you make sure they are working as expected? Now we have these dependencies across different services. Ideally, you want to avoid the dependencies, like the hard dependencies, but sometimes it's very hard to avoid those dependencies. So what happens to your service if AWS goes down, or if Google service goes down? How you will survive? You'll be fine. But what about your software? Question here: who here like feels very comfortable about your application that you're running in the cloud? Like, you feel very comfortable, you sleep very well without any kind of alerting or anything? All right. Oh, do you? Okay, that's good for you. Me too. I'm getting better. But yeah, I mean, we can't prevent like everything. There's always going to be, it's going to hit us, and I think observability is the key, is the word to help us. So observability in the first place is a mathematical concept. It's not just applied to software engineering in general, but it's one of the software engineering pillars for sure. It comes. It was introduced by a Hungarian folk a long time ago. As I mentioned, it applies. If by Wikipedia definition, I would say it is a way to measure a internal state of a system. And this system can be whatever, really, like a mathematical or physical or physics or software. So it's a way for you to measure something inside your application when you bring to the software development world. And this is like open the doors for us for talking about monitoring, alerting, reliability, and remember Ross and friends? If you're not a friends person, don't get this meme, but it's pretty good. Awareness, which is very important for software engineers in my perspective. So monitoring is like your ability of track what's going on in your service, even better if you can do that in real time. Depends of your type of application. Alerting is also another very important concept because you can't be watching dashboards all the day long. Now you're a human being. You also have to do your work, not just watching metrics. So alerting helps you to get notified, like when things, when you need to. And observability also help you in terms of reliability when you can figure out what's going on with your service. Without that, how can you prevent bad things to happen? Or even after that, if something bad happened to your service or to your software, if you don't have any visibility of the impact that happened, that caused in your service, it would be very hard for you to avoid that to happen again. And this is very similar to awareness, and the visibility, the observability also allows you to plan accordingly new features or new releases. You know the impact of something in your application. You can infer what can happen given the different inputs, different situations. This is a quote. It makes way more sense in Portuguese. This is a Portuguese writer, José Saramago, but still makes a lot of sense even in English. It says, like, if you can look, you see, and if you can see, you can observe. If you can observe, obviously gonna makes more sense. it takes your attention. In Portuguese, originally, we have this tricky word with repair and observe has the same meaning. So you can understand this observe also as a repair. So if you can see something, you can repair something that went wrong occasionally. Or even observe, and you can prevent something bad to happen, just understanding the trends of your metrics. And all right, let's talk about Prometheus. I know there is like a lot of monitoring and alerting system, and probably someone is gonna say, okay, but what about Datadog or AWS? Like data wash, I think they call that. There's like a lot of good tooling, and I'm gonna speak about Prometheus first because I'm a big fan, and second because it's open source. But it doesn't mean that's the best tooling ever. It do depend of your necessities. So Prometheus is a multidimensional time series software. So it keeps your data in the time series base. So you have the track of what happened along the time in different formats and shapes. It also offers you a built-in query language, what they call Prometheus query language, PromQL. You can query your data in a SQL fashion. It's like not like really like database, but it's simple enough. And also they have a lot of built-in functions, mathematical functions, statistical function that helps you to visualize and aggregate data together. Prometheus also offer two separate softwares. They work like a plugin, but they are like different applications, part of the Prometheus federation, I would say, which is Alert Manager and Node Exporter. I will talk about them hopefully more in the demo, but basically our Alert Manager keep watching the alerts in Prometheus that you can create using Prometheus data that you generate as a developer, and trigger you in some channel that you configure in Alert Manager. That could be email or Slack or PagerDuty. There's like really different drivers you can configure, and you get notifications in real time. And the alerts are defined as you please. And Node Exporter is also another very handy tooling that you just like install and works right off the box, and it exports metrics from the host. That could be your server, that can be your computer, that can be your Docker container. It's literally about the machine itself. And you get like all the hardware, metrics, CPU, memory, temperature, like really loads and loads of different metrics that you can maybe correlate to the behavior of your application. For example, how my application behaves in terms of hardware consumption when I have like 1 million concurrent requests. That would probably be pretty crazy. And what I think pretty cool about Prometheus, it works in a pool model, so your service doesn't need to send anything out, like you don't need to post information to anywhere, but you just need to expose them. And Prometheus takes care of scrap your service and collect all the metrics that you're exposing and get it to itself. So Prometheus will keep the data on its server, but you don't need to send them. They're going to collect. It's by default in the /matrix endpoint. That's what they call is /matrix. You must have, but it's configurable anyways. And it's also supported. You might ask, like, what if I don't have a service? It's not like a web application. It's just like a cron job or a Lambda function. Prometheus also supports a push model, so you can also post the metrics to somewhere. But in this case, first of all, it should be avoided if you can, because you have like a middleman in this case, which is the push gateway. It's also a Prometheus software, but it's not as reliable as the pull model, because first of all, you have a middleman, and second, from the push gate to Prometheus is also a pull model. So you just like introduce a latency and introduce a single point of failure in your infrastructure. What else? Oh, well, targets are also discovered. So targets are your applications, your services. And Prometheus can easily understand there's a new service, especially when you have like different softwares doing the service discovery in your application, such console. and it can like automatically start scrapping your service without you do anything. And by last, you can plot this data, which is Prometheus basically a lot of text, which is like not very human readable. It is, but like without a nice plot, it's kind of it's not like easy to understand what's going on. And you can use that data like really in different kind of dashboards. Grafana is another open source which we are gonna use today, but you can also use other softwares that support Prometheus drivers. Cool. Prometheus has like 3 main types of metrics. First one is histograms and summaries. They are very similar. The only difference, one automatically offer you like quantile percentiles automatically, and while histogram, you can manually calculate that. Histogram, for those who doesn't know, like is the same math definition. Basically, have buckets. Does that word even exist? Like bucketized objects. Let's say you have objects that fills. You can fill it like in a bucket of this size and smaller and smaller and smaller. You can quantify them using buckets. Gauge is like an arbitrary value. It could be like it goes up and down. It depends depends of the context. You can imagine like as a car accelerating and deaccelerating, so it goes up and down. Y counter is a kind of metric is always go up. It's like it's a counter after all. You just sum it up or reset it to 0. It's very useful for counting things like number of requests, number of errors, number of workers you have like running in the background, these kind of things. And this is how a Prometheus metric looks like. You define the name. It can be whatever you want. Obviously, you want to, as a developer, and you write software to other developers as well, make something meaningful. So you define the name, and you can have labels to help you to filter this among a lot of other metrics you're going to have, and entries of the same metrics. So you can define the labels yourself, and you're going to have a final value, which will be computed by Prometheus after scrapping your metrics. This is one example of using the Prometheus query language. So in the first sentence, I created a metric. This is how it looks like. But then I can query this in the Prometheus database, and I can apply some Prometheus functions on it that will apply mathematical calculations on top of it. And this is like how it looks like in the server side after implemented. In this case, I created this called request duration seconds bucket. And as you can see, you have like a bunch of buckets. Those are the bucket size for in terms of seconds, how long a request took to complete. I have this line, the third one from the bottom. We have like an infinite, which is like the failover. Like if some request takes a lot of time, greater than 10 seconds, which is the smaller one that I have after that, it's going to end up in this bucket, and so on, so on. So Prometheus takes care of select the correct bucket for me and put the request into. Yeah, as I mentioned, like sometimes you have a lot of metrics, beautiful charts, even dashboards in the wall in the office, but you have to shower, have to sleep, you have to take your kids to school, right? You need some sort of mechanism to let you know something bad is happening, or even better, in my opinion. It depends the way that you prefer, but in my opinion, it would be even better you be alerted something bad is going to happen, even before it happens. And you can define like different levels of alerts. When something bad is going to happen, you can be alerted by email, which is okay, right? But something very bad happened, for example, you have no services running at all, you can be alerted by your phone, like some software call you or things like that. And for that is Alert Manager, and Prometheus alerts are very useful. You can define alerts using Prometheus metrics, the same expressions that I showed before. As you can see here, we have this very long alert definition, but summarizing is this expression means if I have like 500 errors increasing more than 2% or whatever percentage you wanna define for more than 15 seconds linearly, I wanna be alerted somehow. And you can create like really whatever you need. Okay, I have 5 minutes. Let's break things. It's already broken anyways. Just want to show some nice things. Let me stop the mirroring. Okay, you can see my terminal, right? So I have a bunch of containers, which I will provide you guys. I will open the code in GitHub. So I have a Docker compose with everything you need. And those are Prometheus, Alert Manager, Node Export, and Grafana. As you can see, they are exposed. I can access them through the browser. And I have a Python application that I wrote as well. Free open source software, PyCon Italy. Pyenv activate PyCon Italy. There we go. So I'm going to run this application. Let's open that, check the code later. Unicorn. Okay, this is running. Meanwhile, I'm going to hit this endpoint very heavily. Let's see what happens. Okay, there we go. So we're gonna hit this endpoint like a couple of times. And meanwhile, I'm gonna show you application real quick. So I have like a very my computer is freezing, is it? I think I hit the service too strongly. There we go, I'm back. There we go. So I have a very simple endpoint. It's not doing anything at all. I call this /home, and this is sleeping for a random seconds, or milliseconds actually, in some case, and returning a JSON. However, I created this middleware. Everybody knows what a middleware is, right? Do something before or after a request. And the middleware is starting a clock when I get a request, do the handler, do whatever it needs to be done, and then I'm creating the labels myself. The labels are the request, the method, in this case get, the path, in this case /home, and the response, the status code, and hopefully going to be 200. And then I have this histogram. Computer's freezing again. There you go, I'm back. And then I have this histogram that I define manually. This comes from the Prometheus client for Python. They support like many languages, in case you're not Pythonist. And then I create this request, or this metric with this name. And this metric is expecting these labels. If I go to my service, and I call this 8,000 /metrics, they are here. And Prometheus will take care of scrapping them for me like time to time. By default, 30 seconds if I'm not mistaken, or 15. So if I keep like using our users using the service, we're going to have more and more metrics. Then we're going to clean up automatically. And then we can plot that in a way. Let me see if I have it configured here. Doesn't look like, anyways. That's what I broke this morning, as you can see. But as I mentioned, Prometheus is very flexible in terms of displaying your data. You don't really need to use Grafana. Grafana is just it's very good, it's very handy. But at the same time, this is the Prometheus dashboard itself. You can see whatever metrics you have, and you can plot them. How it is called ours is HTTP direction seconds. Let's see what happened in the last 5 minutes. What I'm missing here? Oh. Wrong metric. buckets. There we go. Oh, I didn't copy. So Prometheus, as I mentioned, it creates. I didn't copy again. Geez. It creates buckets for a matrix. So I call this HTTP request duration seconds, but he created like a bunch of the same matrix with different size of buckets, depending on how long my request takes. Game over for me. Oh, okay, we got some data. I will release the code and GitHub. I will make it very easy to run in a single command. For now, let me get back to the presentation just to say goodbye. This is my Twitter. This is my GitHub. I will be right in the coffee place. Hit me if you need any kind of discussion, or if you feel like you want to talk about metrics, or even when other subjects. I'll be very open too. And one more time, thank you very much for getting me a full house today.
Thank you, Luis. Time for questions. First one, should I protect access to node exporter, and how?
Sorry, can you say that again?
Should I protect access to node exporter?
Assets.
Access.
Access. Probably, yeah, I would say so. Well, a quick disclaimer here. This is a talk from the software developer perspective. I'm not like a DevOps or infra person. But I would say, yeah, this is I would say all your metrics, unless unless you're using your metrics for the business logic of your software, that should be like something internal. Usually companies deploy this the whole stack, like Prometheus, node exporter, alert manager, especially alert manager, inside the closed infrastructure, so only internals can use that. That would make more sense.
Okay. Do you have any suggestion on how to use Alert Manager efficiently and avoid too much noise, false alarms?
Yeah, it's an excellent question. I think it depends of a lot of different factors. The first one, how mature is your software at the moment? How big is your team? My personal opinion is you can always remove alerts, but missing alerts is kind of dangerous. And you cannot use the severity of the alerts. You can always tweak that accordingly. So let's say if you see something that is trending to be wrong, you don't need to be like wake up in the middle of the night, right? It could be like an MA or something. But if something definitely is wrong, you can use another severity and like maybe wake up someone, because after all, something's really bad happened. I think the short answer is, if you have like a proper on-call rotation, like a big team that nobody gonna be burned out because of like too noisy alerts, and also how mature is your software. If it's like something that's starting, sometimes has like more bugs or it needs more attention. But yeah, you can always like remove noise alerts or tweaks. The first step is always gonna be have the data, understand the data, and then create alerts based on from what you understood.
Okay. What about Grafana alerting? How does it compare to Alert Manager?
It's a good question. I personally never tried. I heard good things about. I'm a big fan of Grafana softwares in general, but I personally never tried the Grafana alerting myself. So it's a good demo for next PyCon. Whoever asks it.
Okay. We are out of time. If you have any question, you can reach Luis. Thanks, Luis.
Very well.